Welcome to the channel where we make statistics simple and easy for everybody to understand. If you are yet to subscribe, kindly subscribe for more knowledge sharing. Today we are going to learn about operation research, specifically linear programming problem. And there is a question here that has been shared with me. And it goes as follows. Glueco produces 3 types of glue and on 3 different production lines. The company has currently 15 workers in total. Workers are paid $500 per week on production line 1, 600 on production line 2, and 700 on production line 3. A week production cost 1,000 to set up production line 1, 2,000 to set up production line 2, 3,000 to set up production line 3. During a week, on a production line, each worker produces the number of units of glue shown in the table below. So these are the number of units of glue in this table here, which are produced per worker. Each week at least 220 units of glue 1, at least 350 units of glue 2. For production to be economically feasible, at least 400 units of glue 3 must be produced. Formulate an IP to minimize the total cost of meeting weekly demands. Finally, the company can either choose to run production line 2 or 3, not both during a week. Formulate and find the optimal solution of this problem. So what do we know here? In this term, what we know that here is that we are working towards minimizing the production cost of a week on weekly demands. And again, what we've been told is that production line 2 and 3 cannot work together. So it is either we choose production line 2 or we choose production line 3. And again, what we've been told is that so production line 1 can work with either 2 or 3. So we have 2 options. We have production line 1 and line 2, and also line 1 and line 3. So the first thing is to determine our decision variable. So let us put our decision variable. A decision variable is that yi we should represent production line. So we have 3 production lines. So we have 1, 2, and 3. And xi is the number of employees. So we have 1, 2, 3. And then we have our objective function. What will be our objective function? Objective function is that we've been told that in Y1, that is production line 1, it will cost 1,000 to set up and 2,000 to set up production line 2. And then each employee is paid 500 to work in to produce glue 1, and each employee will be paid 600 in each week. So each employee will, that is the amount of, because this is where we are being told that for if a worker is working in production line, will be paid 500, 600 in production line 2, and 700 in production line 3. So having been told that, so what are our constraints? The first constraint is the glue types. These are the glue types here. So we are working on the first option, that is using production 1 and 2. And then we'll be having production line 1 and 3. So glue types, we have 20 and 50. And remember, it should be more than 220 units. And then if you're working in 1 and 2, the other constant is 20 and 35. So the number of employees that will be producing in production line 1 and in production line 2 should be, the total units should be greater than 350. Same case in the glue in this one, in the glue type 3. So it should be 40 plus 50 should be greater than or equal to 400. Again, we have the other here, been told that it is x1 and x2. So the number of employees that are going to produce these in these 2 production lines should be less than 15, because we have been told that the company has 15 employees. So let's go to Excel to solve this. So if you go to Excel, the first thing that we've been told is the thing we are labeling our model as determining the number of employees and minimizing. Let me increase here. Exactly. So we are determining the number of employees and minimizing the cost per week. So X1, we've said X1 is the number of employees that are going to produce, that are going to work in production on line 1, and the number of employees that are going to work in production line 2. So the number of, the maximum number should be 15, because so we can decide that all of them to be 15 and this one will not work, all of them to be 15, that will not work. So this is what we are going to look for. Let me color it there. So we need to know how many number of employees are going to work in X1 and how many are going to work in X2. And then the minimum number, so it is 0. So we can have no employees here, we can have, and then the all 15 to be here and the other way. So we come here, the constraints, the way they were just, and then 20, 50, all, if you add these, you're going to be greater than 220. Usually leave a space here just so that I can input my formula. And then the number of employees in production line 1 and production line 2 should be equal to 15. So we need all these employees to be working. And then what is our objective function? Objective function is that we are paying this employee 500 and the other employee we are paying 600. Then now the other thing is the total employee cost. So the total employee cost is going to be given like is equals to be whatever we are going to get here, the objective there. And then we have production line 1. To set up production line 1, no matter what we are doing, it has to be 1,000. Production line 2, it is 2,000. So what is the total cost? So total cost will equal sum all these three. Exactly. So far we know it is 3,000, but we don't know. So let me put them, but we don't know, but we don't have the employee cost. First thing that we need to do is to create the formulas here. So we use some product. So some product. So whatever is going to be multiplied, the number of employees here multiplied by the amount of glue that they're going to produce is going to give us this cost here. So let me cell reference the number of employees that we are looking for, and then I drag it all through down. Exactly. So once you do that, so you go to data, then go to solver. Then we have our objective function as this. This is our objective function. We have a objective function. This is the objective function. And then we are trying to minimize. So when you're trying to changing variable, this is the changing variable here. And then the constraint, so we start adding our constraint. So all these we can just select because it is greater than, should be greater than what? All this. Then we add, and then we have this should be equal 15. Then we add, and then any other thing, yes. So we have the number of employees here. They should be less than 15. Add, and again the number of employees here should be greater than or equal to 0. And then we add. So we have our constraints there. And then we change it to simplex linear programming. So, and then we solve. Here we have our results. But now the interesting part is this. We have our employees as 11.67 and 3.33. So we cannot be able to determine. So what we need to do, we need to tell Excel again, ensure that these figures here, the 11.67 and the 3.33 are integers. So we return to solver parameter dialog. So you click there and you click OK. So we need to add another constraint there, and then we say these values that here, they should be integers, and then we add them. So we go back and now we solve our equation. So once we solve our equation here, it tells us that 11 employees should be working for production line 1, and 4 employees should be working on production line 2. So which will cost them 7,900. After it costs them 7,900, so in total production cost will be what? So let me just click OK here. Total production cost will be 10,900. So follow the same procedures and compute for option 2, and these will be your results for option 2. The results for option 2 will be 11,700. Thank you.